Ever wondered how to improve the performance of your database queries? Welcome to the world of databases, where performance is key. Picture this. The database is the heart of any application, pumping information to every corner of the system. But what happens when this heart starts to slow down? The entire system can become sluggish, affecting user experience and overall efficiency. That's where database performance comes into play. To get our database heart beating strongly and swiftly, we turn to a handy tool known as an index. Much like the index at the back of a book, a database index helps us locate information quickly, boosting the speed of our queries significantly. But how exactly does one create an index? Fear not, it's not as daunting as it might sound. In the next few minutes, we will break down the process of creating an index into simple, easy-to-follow steps. So get ready to supercharge your database performance. First things first, it's crucial to identify which columns you want to index. As we delve deeper into database performance, we need to shine some light on the importance of choosing the right columns for indexing. The ultimate goal here is to enhance the performance of your queries, which means you'll want to focus on those columns that are frequently called upon during filtering or sorting data. Think about it like this: the columns that are most frequently involved in your where or order. By clauses are prime candidates for indexing. These are the columns that your queries often rely on to retrieve the necessary data efficiently. This step requires a good understanding of your application's query patterns and the nature of your data. So, take your time, analyze your queries, understand your data, and make informed decisions about which columns should be indexed. Once you've determined the columns, it's time to choose the type of index. Database systems support various types of indexes, including B-tree, hash, or bitmap indexes. Each of these has its own characteristics and use cases. B-tree indexes, for instance, are highly versatile and suitable for most scenarios. They are designed to work well with a wide range of queries and can handle equality and range queries efficiently. On the other hand, hash indexes are particularly effective when it comes to equality comparisons. They use a hash function to map distinct values to unique keys, making data retrieval exceptionally fast. However, they are not as effective for range queries. Bitmap indexes, while less common, can be incredibly efficient when dealing with columns that have a low number of distinct values. They use bit arrays and bitwise operations to perform queries, making them highly space efficient. Remember, the choice of index type should be based on your specific needs and the nature of your data. Next, we will discuss how to implement these decisions using the create index statement. The create index statement is used to create an index on the chosen columns. This is where the magic happens. You've identified your columns, chosen your index type, and now it's time to craft your statement to bring this index to life. In the world of SQL, the create index statement is your tool of choice. This command allows you to define your index and specify its characteristics. You'll need to provide the index name, the table name, and the column or columns to be indexed. Let's dive into an example. Imagine we have a table called employees, and we want to create an index on the name column. Our create index statement would look like this. Create index IDX underscore employee underscore name on employees, name. Here, create index is our SQL command. IDX underscore employee underscore name is the name we've chosen for our index. Employees is our table, and name is the column we're indexing. It's as simple as that. But why is it so crucial to specify these elements? Well, the index name is important because it allows us to reference the index later on. The table name tells SQL where to create the index, and the column name defines what data the index will cover, so each component plays a key role in creating our index. Now you might be wondering, what happens next? Well, once we've crafted our create index statement, it's time to execute it in our SQL environment. This is where your index will start to take shape, as SQL processes your command and creates your index in the database. Remember, the create index statement is a powerful tool. It allows you to enhance your database performance by enabling faster data retrieval. But like any tool, it requires careful handling. Be sure to choose your index name, table, and columns wisely to ensure your index serves its purpose effectively. Now that we have our create index statement, it's time to execute it in our SQL environment. Let's move on to the next step in our journey towards improved database performance. Execution is just as important as preparation. Now that we've created our index statement, it's time to bring it to life. In the SQL environment, Executing a statement is as simple as running it, so we'll take our create index statement and execute it. This will create our index within the database. For example, if our statement was create index IDX underscore employee underscore name on employees name, clicking run or execute in our SQL environment will create the index named IDX underscore employee underscore name on the name column of the employees table. After execution, we need to verify the creation of our index. This is a crucial step to ensure that our index has been set up correctly and is ready to improve our query performance. We can do this by listing the indexes in the database or by describing the structure of the index. To list all the indexes in the current database in MySQL, we can use the command show index from employees. This will display a list of all indexes from the employees table, and if our index has been created successfully, IDX underscore employee underscore name should appear on this list. If we want to inspect the structure of our specific index, we can use the command show create index IDX underscore employee underscore name. This will give us a detailed overview of our index structure, showing how it's been set up and confirming that it's ready to improve our query performance. But remember, creating an index isn't a one-size-fits-all solution. There are considerations to keep in mind. Indexes can improve query performance, but they require additional storage space and may impact the performance of data modification operations like insert, update, delete. So, it's essential to consider the columns you need to index carefully, based on your application's query patterns and performance requirements. Creating an index is not a one-size-fits-all solution. There are some considerations to keep in mind. While indexes can improve query performance, they also require additional storage space and may impact the performance of data modification operations. Indeed, as much as indexes can speed up data retrieval, they do have their trade-offs. One of these is the additional storage space they require. An index, after all, is a data structure stored separately from the table it's indexing. This means that every time you create an index, you're essentially duplicating some of the data in your database, which necessarily takes up more space. Another key consideration is the impact of indexes on data modification operations, such as insert, update, and delete. When these operations modify the data in indexed columns, the database system also needs to update the corresponding indexes. This additional work can slow down data modification operations, especially in large tables with multiple indexes. So, while you're keen on speeding up your queries, you must also weigh these factors carefully. The decision to create an index should be based on your application's specific query patterns and performance requirements. For instance, if your application frequently reads data but rarely modifies it, then the benefits of indexing may outweigh the costs. But what if you've created an index and later decide it's no longer needed? Or perhaps the index is causing more performance issues than it's solving? Well, you're not stuck with it. You can drop the index using the drop index statement. For instance, to remove the index named IDX underscore employee underscore name from the employees table, you would use drop index IDX underscore employee underscore name on employees. This statement tells the database system to remove the index, freeing up the storage space it was using and eliminating any impact it may have been having on data modification operations. Remember, indexes are powerful tools, but they're not a one-size-fits-all solution. They require careful consideration and ongoing management to ensure they're benefiting your database performance more than they're hindering it. By following these steps, you can create an index in your database system to improve the performance of your frequently accessed columns. Creating an index is an essential skill for any database administrator. Today, we've navigated the process together, starting with the identification of key columns that are frequently used in your queries. We've explored the various types of indexes, with B-tree indexes being the most common, and you've learned to tailor your choice based on your database system's capabilities. Together, we've crafted the create index statement, specifying the index name, table name, and columns to be indexed. We then executed this statement in the SQL environment and verified its creation. We've also touched on the importance of considering the impact on storage space and data modification operations, and how to drop an index when it's no longer needed. With this knowledge, you are now ready to enhance the performance of your database queries. Do remember, with great power comes great responsibility. Use your indexing powers wisely.